Yep.
So should we start directly, Chaitanya?
Just, just a
Okay.
minute.
Yeah,
Yeah.
sure.
Good afternoon, everyone. Welcome to Kotlin Hyderabad, August 1st edition. Today we are going to have a talk on Introduction to Kotlin by Siddhesh Patil. Uh, yeah, this Siddhesh, can you start over?
Yes, yes, sure, sure. All right. So thanks, Chaitanya. Thanks, Kotlin Hyderabad, for having me here to talk about introduction to Kotlin, right? So this talk is primarily centered around introduction to Kotlin. This is intended for beginners and newcomers who want to learn Kotlin. So this is a fairly introductory talk. We'll go through some specifics on Kotlin, some basics of Kotlin, and we'll deep dive into some of the implementations as well. So this is a fairly intermediate, starter level talk, you can say, not intermediate. This is a fairly beginner level talk. So let's get started. So first I'll start with introduction. So my name is Siddhesh Patil. I work on Paytm's apps for Android and iOS. So Paytm is a big payments platform in India, and I work on Paytm's apps on multiple business verticals like movie ticketing, event ticketing, so all forms of entertainment ticketing in general. Also, currently I'm working on some form of user to user, user to merchant chat features that are there. So so those are some of the things that I do with. Just a second. I think there is some issue with my mic. Okay. Okay. All right. Sorry about that. So yeah. So at Paytm, I primarily work on event ticketing and movie ticketing, and I also work on some of the chat features, like I said, user to user or user to merchant kind of payment chat features that are there. That I work on those as well. Before working at Paytm, I worked with banks like Axis Bank, Yes Bank. So these are some of the top banks in India, and some insurance companies also. So I've led a tech team to ship out software that is being used by their employees right now in these banks. So that's some of the stuff I've done before Paytm. I also organize a community called Kotlin Mumbai. So Kotlin Mumbai is a developer community which is centered around Android and Kotlin. It's very similar to what Kotlin Hyderabad is. It's a user group by Jetbrains. So you can check that out as well. You can have attend some of our meetups that we do at Kotlin Mumbai. I am also a Google community lead and a part of Google's community leads platform. So if you want to connect with me, the best place to connect with me is my website, which is truestock.com, or you can uh, follow me on Twitter and message me there if you want to connect. Okay, so yeah, so this is my website. Basically, I blog about events, what's new in Android, and what's new in Kotlin. If you want to go through some of my work that I've done previously, this is the best place to go to. And you can, as you can see, there are multiple links there for LinkedIn and Medium and some of the articles that I've written there as well. So if you want to connect, check out my work and know about me in further detail, this is the best place to go to. Cool. So let's start with the topic for today, and I'll start with something very simple and ask a question: why Kotlin, right? So why should you consider Kotlin? Why should you be concerned with this language, and why should you prefer Kotlin in the first place? So Kotlin is one of the first, and first and foremost preferred language for Android development. It is one of the fastest growing programming languages. So it has taken over other languages like Scala and Clojure, and it is growing much more faster than those. And it is the preferred language for Android development. So Android has gone full ahead with Kotlin first around 2 3 years ago or so, around 2017 or so. uh, Google announced that they are going to be supporting Kotlin first as their programming language. So if you start a project even right now with Android Studio, you will see that by default it selects Kotlin, and that's a big reason to, if you are into Android development and if you want to learn mobile development, then Kotlin is a must. Okay, so Kotlin is also simple and easy. Okay, it's a very easy and a simple language to learn. It's not that difficult. It's fairly easy than other object-oriented programming languages, and we will see why that is the case as we deep dive further into the session. Okay, and transitioning from Java to Kotlin is fairly easy. Okay, so If you're already a mobile developer, if you already know Java, then Kotlin is super easy to learn. So that's something you should look for if you already are a Java developer. And there has been research done on how many developers use Kotlin. The Android development team and the team at JetBrains, they have done sort of research on this, and they have found that Kotlin is showing high levels of productivity with developers. So developers are more efficient. They are they can code much more efficiently while using Kotlin. So there's data to prove this, and the Android team and Google team is pretty vocal about it as well. So that's why you should consider Kotlin. Some fun facts about Kotlin. Kotlin was first announced in 2011. Okay, so it's fairly old in that sense. So it's almost 9 years now since it first got announced. And Kotlin's lead designer is Andrei Breslov. He's a really cool guy. You can check out his videos on YouTube, and he has given talks at Google I/O. You can follow him on Twitter. He's the lead designer for this. And JetBrains, which is the company, IntelliJ, they take care of Kotlin. They basically fund and support the entire process of language development and the entire resources that it requires. So JetBrains takes care of the language development. They basically fund the research and support the overall language development. Also, Kotlin is named after an island. So Java, as it is named after a coffee bean, there is also an island called Java. So this is a fun fact. So when they were naming Kotlin, they used this name for an island which is near St. Petersburg. So it's Kotlin Island is an actual place, and that's, if you're wondering where the name Kotlin comes from, it comes from this island. So that is some of the fun fact about Kotlin. Okay, what is Kotlin? If I ask you what Kotlin is and how will you define it, right? What will you say are some of the best things about Kotlin? How will you say that in a sweet and short way? Okay, so Kotlin is a statically typed programming language. So what do I mean by statically typed programming language? So statically typed means that it has types that get known at compile time rather than run time. Okay, so types as such as integer, data, whatever type you specify for any declaration, that becomes available at compile time rather than runtime. That's what we mean by statically typed. So Kotlin has type inference, but it is still a statically typed programming language. It's general purpose. So what do I mean by general purpose? It doesn't have a special dedicated purpose. That's what Kotlin is made for. It can be used anywhere, and you will see that pretty much everywhere where there are server deployments being done on Kotlin. Kotlin primarily is used for Android development, but it's not a special purpose as such, or made to only do one thing. Then it borrows a lot of features from C Sharp, Java, and Scala. So C Sharp, Java, Scala, those are other object-oriented programming languages, and those have been derived from obviously the first language, one of the primary languages for object-oriented that came into being, which is C++. Right, when Bianis Trustrup, who wrote C++, he got that from Simula, which was way back in 1950s or 60s. He got the object-oriented programming concept, put that on C, and that's why he made C++. And then other languages like Java, C Sharp, Scala followed. Java being, very platform independent in that sense, that you can write once and run it everywhere. So a lot of these languages have evolved, and Kotlin also learns from these older and mature languages. So it takes the best from them. Okay, so now let's talk about JVM. So Kotlin is primarily targeted for JVM. So JVM is your Java virtual machine. So it primarily targets that, but it also can compile code to JavaScript or native code. Okay, so what do I mean by JavaScript or native code? It means that you don't necessarily need to run it on JVM or just a very Android specific environment. You can run it on, it can compile down to JavaScript if there is a JavaScript friendly runtime environment that is there, execution environment, then you can have that code. It also compiles down to native code. So what I mean by native code is, basically you have LLVM. LLVM is a set of collections of compilers as such that help you compile code into a certain native level code, right? So LLVM is a tool chain in particular, and Kotlin can compile down to that code. So if I have to in short say what Kotlin is, Kotlin is a statically typed language. It's a general purpose language. It derives a lot of features from other object oriented languages, and it primarily targets JVM. So that's what Kotlin is. Now let's talk about interoperability and tools. So Kotlin is fully interoperable with Java. You don't have to worry about anything if you are already a Java developer. You don't even need to know some specifics while getting started with Kotlin. You can directly get started, in fact, because interoperability is a big topic that is addressed already with Kotlin. Kotlin code and Java code can both work together in a sense. In fact, Java classes can be converted directly to Kotlin. The IDs, in fact, offer these tools and environments to convert your Java code to Kotlin. So if you copy a Java code to clipboard and just command V or copy paste it into the ID on a Kotlin file, it will ask you, do you want to convert the code Java code to Kotlin? It's that easy to convert code right now. And JetBrains ID, primarily the Android Studio that most Android developers use, that these IDs offer this direct conversion. Kotlin also can be done obviously just without any mobile IDs, development IDs, or anything of that sort. You can just use JDK and compile Kotlin. So tools to use are JDK, definitely the Android Studio, and other IntelliJ IDs that are there. So these are some of the things with interoperability. Cool. Now let's go into some specifics and let's learn about what are some of the values and variables and what are some of these keywords that you use with Kotlin, and how you can get started with some of the basics while learning these things. So I have divided this entire session into 10 small chapters, which we'll go through very quickly. And these slides are also divided in a sense where I first talk about something, we explain and get a clear idea of what we are talking about, and then I'll show you a code example of that. So first thing is values and variables. So for anything to be declared onto your code, you have to use this, right? So what is a val and what is a var? So these are the keywords you use for declarations, which is a val and a var. So val is a value that once you set it, you cannot change it ever. It's one set, it'll always be that until basically the program just closes and it's out of memory. Till that point, that value will hold a certain value. You cannot change it. If you try to change it, it will show an error. A var is a variable, on the other hand, and it can be reassigned. You can assign another value. So how how do we see this in a code example? Okay, so let's take a look at the example. I hope you can see this clearly. I'm just going to check if the stream is proper. Okay, cool. So I think it's going well. So in this example, what I have done is I have declared a val, which is an ID. Okay, and it has a value of 201. It can have any value. And then there is a var, which is a variable. It can have a variable value and you can change it. I have assigned it a value of Hyderabad. So let's say if I try to reassign a value to the ID, it's not possible. The compiler will throw an error, it will not compile. In the same sense, if I try to assign another value to location, which is a variable here, it is possible because variables you can assign values again. So this in basic, just val and var are what we use for declarations. Moving on with typecasting and inference. So remember how I said previously what statically typed means? So Kotlin offers type inference. Okay, so Kotlin offers type inference in a sense that so okay, let me first cover what type inference means, right? And why is type inferencing important? So let me go back to the example here and show you guys how this is done, right? So in where I've declared ID and location, notice how I'm not specifying that it's a string or an integer or a double or whatever. I'm not specifying a type here. This is one of the features of Kotlin. Kotlin has type inference built into it, but Kotlin still is statically typed. So how does that work? Okay, so Kotlin, while being statically typed, it means that all of these declarations that are there, where I'm not mentioning a type, they become inferred at compile time. So when your code compiles, the compiler sort of Kotlin's compiler figures it out and says, okay, this is an integer or this is a string. So that's what I mean by type inference. So Kotlin is statically typed, yet it has type inference at compile time. And we offer explicit typecasting, and, that is also available for you guys to mention if you are so careful about the code that you write. If you explicitly want a variable or a value to have a certain type, then you can have explicit casting as well. So let's take a look at the example of this. So here I have an example. So again, we have the same example. I have a name and an ID from the last example. And here, if you notice that I have used this int over here and a string over here with a colon. So what does this mean? This tells the compiler that this variable or a value is of type this data type. So the compiler sort of doesn't have to figure it out, at later stages of what needs to be done. Uh, yeah, so that's what I mean by type inference. And just a second, guys. I think I'm getting an issue with the connection. Sorry about it. Okay, I think it's better now. Okay, so with type inference, what I mean by that is basically you can just have a type specified when you declare something. So this first example talks about explicit declaration, and this next example, which is inferred. So here, if you notice the last example also, we did not specify that it is a string or an integer. The compiler figured it out. So this is what we call as an inferred type. So this is one way you do that, and that's the freedom that Kotlin offers you while you make your classes and declare them and use objects. Okay. So now we'll see assignment with typecast. So here I have another variable called another name, and I am assigning it the value of name, but I'm taking it as string. So you can, if you want to explicitly use typecast while you're assigning, you can use this keyword as. So you say name as string. So that's what you do. Okay. And then if you want to check if a certain variable or a value is of a certain type, then you check, then you use this keyword is, basically. So if you are doing a conditional checking over here, then if you say if name is string, and if it's value is true, then something will happen. So you can check type like this. So this is in short a detail about typecasting and inference. Okay. So that's some basic. Now let's cover nullability. So here is where Kotlin becomes very powerful, right? Because Kotlin offers null safe, null safety features inbuilt into it, and Kotlin is designed that way to be null safe. So what is nullability in the first place? So nullability is the ability of any variable or any declaration to hold a null value, right? For example, the last example, I said ID equal to 201. I can have that as a null value as well if I want to, but that might break my code in the future. Let's say I've not assigned it a value, but I'm using it in the code, then that might cause a big problem, and then my entire code can break, and then a mistake can happen. So that's what we call as a $1 billion mistake, because these null pointer exceptions that happen where a value is null and some code breaks, a lot of business gets affected by that at times. And that's why programmers, Java programmers, are very familiar with this, where we write code in such a way that if this is not equal to null, then only do this. So with Kotlin, you have to forget about all of that. We don't need to do all of that. Kotlin is very null safe when it's in its design itself. So Kotlin offers null safe and nullable types. So let's take a look at those. So here I have an example. So here I have declared a name, which is again from the previous example, and this is null safe. Now, why is this null safe? It's because I'm already declaring it a value and it's not null, right? Kotlin by default, when you write something, it takes that as a non-null, basically as a value that cannot have a null. Okay. So what I mean by that is it's already null safe. But now if you, let's say, want explicitly to have a null value in a certain variable, then you can put this question mark in front of it. For example, here I have this class person. So I have defined it at bottom here. Okay. And we don't need to go into specifics what a class is and what a data class is, for just for the namesake. Right now, understand that this is a class, and we are just making an object out of it, right? And I'm assigning it null value. So if you look at example number 3 over here, where I've mentioned safe calls, then we are putting a question mark in front of it. So what does that mean? So this is what we call as a safe call in Kotlin. Okay. So if, let's say, even if a value is nullable, that means it can have a null value, and you want to use it somewhere. So what happens if you use that? And definitely you could get a null pointer exception if it was Java. But in Kotlin, if you have to use it, Kotlin will not allow it in the first place to use a null value. So to make a call, you have to either make a safe call, or you have to tell Kotlin, okay, ignore this problem. I know that I have put a null value, and I will handle this. So here are two examples of that. One is where we put a question mark dot last name. So basically, I'm trying to access a property inside this person class, which is called a last name, and I'm doing that on a null object. So that's why this safety operator is there. And then if I want to ignore safety altogether, then I'm putting two exclamation marks. So that's how you ignore safety. If you directly want something to be null, and you can handle that in your code, then you can put a double exclamation mark. Now I will advise you guys to not do this, because Kotlin itself is designed in a way where you can avoid null pointer errors altogether. So to take the best advantage of Kotlin, you should definitely use these safe call features and nullable and null safe features altogether in the best way possible. So this is an example of nullability. Kotlin is null safe in nature. Okay, so now let's move on to functions. So what are functions? Functions are basically methods. You all know what methods are if you are familiar with object oriented. A class can have methods. A method is basically a function that does something. So in Kotlin, we declare methods with the fun keyword. Okay, so that's the first thing. And Kotlin offers top level functions. We will know what these top level functions are in the future slide. But if you want to declare just a method, then you have the parameters for the method that you define with round brackets, and the body is written with curly braces. Okay, so this is very basic function syntax that you can write. And then methods can have return types also, which are defined by colon and then type. So we'll take a look at that in a much better way in the example. So here we have functions. So functions are basically, first, here are three functions. So first function here is a very simple function. So it's saying function hello Kotliners, and it's just doing something. So this is how you define a method or a function. So when I use the word method or function in this entire presentation, it means this one and the same thing. You are free to use whatever term you want, but we call them as functions in Kotlin with the fun keyword. In the second example, there are a lot of things happening here. So let's take a look. So it says hello Kotlin with name. So what does it do? So it is taking a parameter which is name, and that name is of type string, which is defined by that semicolon string type of explicit mention over there. And you have to define this when you are taking parameters. So this function is taking in a parameter, and then it's printing that name out. So notice how the string is printed. I have put a $ dot name. So in Kotlin, you have to you don't have to do all kinds of string building and all of that. Kotlin itself offers string interpolation. So what does that mean? It means that you can modify string as and when you want by just using this $. So here the name is a property, or it could be anything, a variable. It could be a local variable as well. But I can use that in my string directly by using a $. Same way, if it's an integer, any other value, you can just directly use it. No need for appending strings with string 1 plus string 2 plus string 3. No need to do all of that. You can just directly write a string like this pattern. So this function is taking in a parameter. This is how you have a parameter for a method. The last one is a simple function which has a return type. So return type is Boolean there, again, that is specified. And I'm just returning the value as true, because of course Kotlin is fun. So you can have return types as well, and this is how you define a return type. In Java, you would probably write something like void or Boolean, then function name, and then function. Here you specify the type or the return type like this. Okay, so that is about functions. And notice how I've put public and private modifiers. So if you want to put a modifier for a function, this is how you do that, just as same as Java. You can have public, private, anything, any kind of access level protection you want to put on a method. So these are functions. Now, what are top level functions? I mentioned something called top level, right? So this is where Kotlin gets, very interesting, because it offers something called as top level functions. So usually, if you have to put a method into, use or define it somewhere in Java, you would have to write a class, then put that method inside it, and then call it somewhere wherever you are calling it. But in this Kotlin top level function, basically what here is happening is you have a file, direct Kotlin file, and you are just writing a function inside it. No need for classes, no need for any of that stuff. You can directly write a function or a method directly in a Kotlin file. So this is what we call as top level functions, and these functions can then be used anywhere, even in Java code. So that's how powerful this is. No need to have separate classes, separate singleton classes for just some functions, some helper classes. You can just directly put this into one file and make something happen there. So that's top level functions. Now we'll take a look at data types. So Kotlin offers data types, of course. Data types are very basic things, and obviously it uses object for its implementation. Everything in Java also is the super object of all objects is sort of still an object. Any class, it's still super object is an object. So in Kotlin also that same thing is there. Objects are used for their implementation, and Kotlin offers primitive data types. So primitive data types, what are those? Those are integers, long, float, a character, which is a character, a string, and a boolean. So you can have these primitive types. They get directly to the bytecode, and here we'll see an example of a data type. So I have id which is int and its value is 1, and then a float, and I have declared a float using just another notation. I've just put a f in front of it. That's how we declare float. And notice how these are obviously explicitly typecasted to demonstrate. If I would have just removed the int, float, and long typecasting, it still will work because Kotlin can figure that out. But for demonstration, what are the data types Kotlin offers? Here are some. So string we have boolean, we have char, long, float, and int. These are some data types. Okay, moving on. Now this part of the section, we are going to talk about flow control. So flow control is having things to do with if, for, switch cases, while loops, things like that. So for better understanding, I've divided this into multiple sections, and we have what we call as conditional checking. Conditional checking is basic. You've seen that in the previous example. So here we have if statements. So if we want to check something and check a condition, if it becomes true or if something is happening in the way it should happen, then we use if cases for conditional checking. So syntax is very simple. If, round brackets, we define whatever condition we want to check, and then the curly braces and the code for that execution. So that's the syntax. And we can use else if for more conditions to extend the blocks and check multiple conditions in the same if else statement. And we can have a default else condition as well if none of the conditions match. So as a quick example of this is, I've defined a boolean here. It's checking if the boolean is true. If not, it's going to the else loop. Same way, there is a variable id over here. I've assigned it a value of 0. Kotlin is again inferring the type of this, and then here there is an example of if and else if. So if my id is 0, this condition will meet. I have extended that further by saying else if what if id is something more than 1, then it will do this. So now this is a very crude example of it, just to showcase there are much better ways to write checks like this, and we will see that in the further slides. So this is basic conditional checking for you all. Now we'll talk about when expression. So what is the when expression, and why do you need a when expression in the first place? Okay. So when expressions are basically simple switch cases that you used to do in Java. So what does a switch case do? It has basically a switch block will have, it takes something and then it'll go through multiple cases and check if the case fits for the parameter that is there, and if it meets, it will execute something. So we don't have switch in Kotlin. It's instead changed with when. So we have something much better than a switch statement. So this is what we call as a when expression. So it's a replacement, and it is we have to use the when keyword to define it, obviously, and then we can define directly cases, and there is no need for breaks. So in switch cases in Java, you would write code like case 0, then do this, and then break. If you don't write the break, it'll go to the other case as well. So that was something of a thing you had to look for, right? But with Kotlin, you don't have to do all of that with when expression. And we use a separator, which is denoted by a hyphen and an angular bracket. So we'll see what that means. Okay, so you will see this sign, which is a separator sign, all over Kotlin things we use. So we'll see what that means for a when expression. So here's an example of a when expression, and we have a variable which is age, and I've defined the age as 21. And it could be anything, right? But here's a when block, right? So in the when block, I'm taking in the age, and then it's meeting certain conditions. Okay, so if my age is 10, then it is doing this. If my age is 21, then it's going to do this. And there is a default else fallback. So if none of the conditions meet, it is going to do that. Notice how there is no break statements. And and that's a part of the when blocks, because you can just directly use them. You can use multiple things like ranges, and multiple checks you can add. We'll learn about ranges as well as we go on. But for a basic when block, if you want to write something which is similar to a switch case, then this is how you do that. So far you've noticed the code, and we've gone through, and you have seen that there are no semicolons I'm writing. And in Kotlin, you don't need to write semicolons while you're making a statement. So if you were in engineering, and if you were a student once, then you know what I'm talking about, because we had those assignments where you will miss a semicolon and the program won't compile. So none of that is a concern in Kotlin. You can just write a statement and forget about semicolons. Kotlin will figure that out for yourself, right? So you can write code in without semicolons. You can mention semicolons as well, but again, the compiler is just going to ignore them, right? So better way to do this is this. So if you're transitioning from Java, this is one thing you should look for. So this is a when statement. Now let's talk about lists and arrays. Now we'll cover something we call as range in the when statement, and I referred to something of that sort. So let's see what ranges are also in the upcoming slides. So with first we have to cover lists and arrays. So what are lists and arrays? So arrays are implemented. So arrays already are a class, they are implemented, while lists are interfaces. So we'll know that a bit more in detail in the last slides. What are interfaces, what are classes, what the implementation of a class interface is. But for now, all you have to worry about is arrays are already made. They have fixed regions in memory, and they have a defined size. So if you start an array with 5 elements, that size will remain that five of a size length basically. And in lists are interfaces. Okay, so what interface basically needs to be implemented. Okay, so the implementation of list is a linked list and array list. Okay, these are two types of list implementation, and arrays can be declared or made using the word array of, and list can be made using list of, and lists can be mutable or immutable. Okay, so what do I mean by mutability and immutability? So mutable means you can change the elements inside the list. Immutable means you cannot do that. So that's what mutability and immutability means in short, where we are concerned with lists. So let's take a look at an example. So there are a lot of things happening again over here. I have 4 declarations. We'll go through them one by one. First one is a number array. Okay, so what is the number array here? It's an array of, like I said, you declare an array with the keyword array of. Okay, so this is what this is going to do is it's going to create an array which has these 5 elements inside it, which are integers. Okay, you can specify type, of course, as well, but here for the example and the simplicity of it all, we are just having an array which has 5 elements. The second one is a name list. Okay, and I've said it's a list of, and these 4 names are there. So these 4 names are borrowed from one of the TV series, popular sitcoms, that is their Big Bang Theory. So I have 4 names of people over here. So this makes a list of these 4 names that I've passed, which are strings. So now let's say what if I want to explicitly mention what type of list is this? Okay, what type of elements can be contained into this? So here I have another example where I've said this is last name list, and this is a list of, and I've defined the type over there. So this is how you define a type for the type of elements to be stored in a list. Okay, so here it's storing a list of last name, which are type of string, and I have the 4 last names of these 4 gentlemen whose names are there. Then we have something called as mutable list. So this is an example of mutable list. So how do you declare a mutable list? You have mutable list of, which is very simple. Again, I have mentioned a type here, and I've just put some random strings into it, for example. So this is how you declare some very basic level of lists, how you instantiate them, how you can add certain elements into the list. Now let's say if I want to access some of the elements in the list, then what I'm going to do is I'm going to say last name list, and then it's going to take that element. We denote that by uh, a square bracket over here, which will pick that from index. There are two ways of accessing an element for a given index. One is using get, and another one is using the square brackets that are there. The good practice to do is use the square brackets. It just directly indexes and picks that element for you. Okay. Now let's say, what if I want to add another element to a list? So you can't do that to immutable list. You can't do it. You won't see the method there, the method to add or remove or do things like that, because immutable, you can't modify that. So with mutable list, I can add. So in the last example that is there, which is mutable list, I have added an element which is E5. So it will add that to the list. So this is how you make lists. Now so far we have covered values, variables, we have covered functions, we have covered top level functions, we have covered how to have a return type for a function. We have checked nullability, and we went through some conditional checking, and we have lists now. So far we have covered very seven brief topics that are there about any programming language in general, right? So now let's talk about iteration. So what is iteration? Iteration again is a simple thing. You iterate through something, right? You go through an object one by one, or you go through an item one by one and do something with that. So that's what we use iteration for. And iteration can be negative, positive. So if you remember code you have written on college level, it's something going to be something like I equal to zero, semicolon, I less than this, and then I plus plus, and then you just index and do all that kind of stuff that we would usually do. So that's what iteration is. You just loop through certain things, and we use for loops for doing this. For loops can be of multiple types. There is no explicit such type that you can say there is for each loop or so, but there are use cases for that, and that's what I'm going to mention. So we have for each loop case that we are going to iterate a list of objects and then do something with it. Then we have indices, we can directly access the index, right? And then we will also learn about the range expression that I spoke about previously. So let's take a look at the example. So here's the example. I have two people over here. So person is a class that I've borrowed from the last example, and person has a first name and a last name. So I have two people here, two famous people, Bill Gates and Steve Jobs. So person one and person two are there, and then I've made a list called person list. And like we saw in the last example, you declare a list with list of. I specified the type here as person. In the last example, it was string. Here, this list can only contain of type person. So we have that here, and these two people I have just added to the list while I instantiated. So now I have a list of people. It contains two people, Bill and Steve, and then now we'll go through the iteration. So how do you iterate? The first example that is there for iteration is a for each loop, what we call as. Okay. So how do you write this? So in Java, you would probably have to write something for, let's say, an item, and then colon in this list, and then iterate that. Similarly, in Kotlin, you also write it, but instead of writing a colon, you write it with the word in. So here, how do I read this statement, right? So what this for each loop is doing is it's saying for every person in person list, do something. So it'll go through every person object that is there in the list and it'll execute the code. So here it's basically checking if a person name is equal to Steve. This equals is a function of string, and I'm this true value that is there beside Steve is basically asking it to ignore the case. In Java, you had equals ignore case. This is how we do in Kotlin. And there are many such small methods. We are not going to cover that in detail because that's a conversation for another day. But iteration in general is going to be like this, where you have a list of objects, you use for each and say the way you read this is for every person in person list, do something. Now here the keyword person is not important. I can just say anything for like item in person list, and then use item dot name dot equals. You can name it anything. So there is no definition for that. That's for our understanding and our readability that we define it. So that's a for each loop. In the next example, we are going to go through indices. So if you want to access the index, basically you do that in a for loop again, and you say I in person list dot indices. That's how you access the index of a certain list, and then iterate through that. And what are you going to do with this index? You're probably going to access that object inside that list with the given index. Okay. So now last example is a little bit fun, where we have a very simple loop which is void of the above examples that I've mentioned. It's a very simple loop, and what it's doing is it's just looping twice, right? So if I ask you to write for loop in a previous language like C++, you would write the standard way of doing it, right? The I equal to 0, I less than equal to 10, and then I plus plus, and then do something with that index, which is I. In Kotlin, you can just range through. So what does that range through mean? So we define a range by saying there is a number, which is the starting index, and then the final number. So it's the way you do that is put double dot dot and then say two, and then it will range to that. So this loop will run twice because that I will be for the range of that index, and the range here is two. So here we can have anything of a range. We can say range 0 to 100. So it will run 100 times. So this is how you would write a for loop. With a basic simple explanation of how you can implement a iterative loop. So this is iteration for you all. Now let's talk about the last part of our discussion before we wrap it up. So classes and interfaces are there. So we saw a couple of classes in the previous example, but everything in object oriented at the base level is a class, right? Like it goes down to an object level. So a class is any container you would want to do something in. It can do many things. It can be a data class, things like that. So how do you declare a class? Class is declared with a class keyword, okay? And then it can have properties in the constructor. So what do I mean by properties? It can have some sort of parameters it can take while instantiating an object, and we can instantiate that object of that class using the constructor keyword, or we can use a shorthand explanation for that, declaration for that, and that's how we can declare classes. Or we can use one-liner data classes if data classes is what you are getting into, and we can do that without getters and setters. So how do we do that, and what do I mean by that? We'll take a look at that in the this example. So here I have a basic declaration of a class. I have a class called student, and it's a very simple class declaration, just the way you do that in Java. And here the constructor is empty in the first one. It's not doing anything. Now let's say I want to declare it with property. Now this is the primary constructor over here, just shorthand expression of declaring a construction. It's taking in a value called name, which is of type string. So anytime you make an instance of this class student, it will ask you that it needs the name. So if I just can quickly go back to this example of person here, this is a good example of how you can make a class with the property that you have defined, right? So here two properties are there. It is taking first name and last name. So that's what a constructor does. It helps you construct a class. And you can define this in a further, more legible way where you say class student and then constructor and then have that constructor. You can have a secondary constructor also. We are not going to get deep into that right now. Okay. So this is basic declaration of classes that are there. And then there is something called as a data class. Okay. So data class is, so if you have coded on API levels where you're making some sort of data models or some just a data holder in general, then you would have come across terms like model, data model, or even something of a being, right? So these are some of the terminologies we use in Java. So in Kotlin, you can just directly declare a class in just one line. So we use that with the class, and what we do is we just have the keyword data before that. That makes the class data class, and all the getters and setters, you don't have to define that when you are making this happen, right? Because in Java, if you make a class, you would have to have like the properties set, and then have to write methods like get name, set name, get last name, set last name, and you would have to make a class like that. So it goes around 10, 12 lines when you make a class like that in Java. But if you do that in Kotlin, you don't have to do any of that. You can just write one single line of class, and it will do the getters and setters for you automatically. Okay, so that's classes and interfaces. Now let's take a look at interfaces in general, just a quick overview. So this is, I know there's a lot happening here, but let's try to understand what's happening. So interface, just the way in Java you declare an interface, you can declare an interface in Kotlin using the interface word, and then have any methods that you sort of want to write. So what an interface does is it's a way to do things in general. So an interface, you define a certain standard. Now this goes into class design, and when you're architecting something, you know that there are certain things that are going to happen, and you want to define them in one place so that that standardization gets applied to anything, any other class that works with similar code. So you have interfaces for that. So interfaces here, as an example, I have an interface called on sunrise listener, a very generic, crude example here. But it has two methods, which says sunrise has happened and no sunrise has happened. So there are two methods that I've defined. And how do I declare an interface, or implement an interface? In the next line, you see sample implementation. I've said uh, sunrise handle is a class and it implements this class. So the way you implement is again, you use a colon and then implement that interface, and then you will have to implement the methods as well of the interface. Okay, so that's the implementation of an interface. And in the last class that you're seeing, which is some class, now let's pay attention here and see what's happening. So to those of you who are familiar with callbacks, you already know what's going on here. But for newcomers, there, let's say you want to do something after an event has occurred, right? Let's say there is some code that has executed, and then you want to be notified of it. So the basic way you do that is through a callback. So you can use interface for callbacks, but interfaces are much more powerful than just being used for callback. But this is a good example of how you can use an interface. So in Kotlin, I have declared an interface. I've named it just on sunrise listener, and it's of type, again, the listener, and I am defining that listener over here. And then I'm overriding the methods that are already defined here. This is what I meant by having some standard way of doing that, because any class that implements a certain interface, that class will have to override its methods and do something with it. Now, this is a clearly a very simple instance of a interface. And then there is a method called initiate sunrise. So in this method, I'm taking the parameter of this interface, and then let's say the function is initiating sunrise, it's doing something, and at the end, I need to be notified of it, right? So I'm just saying on sunrise listener, which is passed, and I'm saying no sunrise happened if, let's say, there is some error occurred, and then it will go to the code which is handle error. Now, this is how you do a callback kind of strategy with interfaces in Kotlin and in OOP in general. Okay. So that is classes and interface for you all. And I think we have covered up pretty much a lot of basics today here. So to summarize this, val and var are the declaration types you use for having any value. And then you have Kotlin has typecasting and it has inferences for typecasting. So Kotlin automatically figures out which type of declaration that you have. You don't need to specify that. It has nullability and null safety. It is designed around null safety. So no more $1 billion mistakes, and you can assure to be having your code which is null safe, right? If you write it in the sense Kotlin is made to write it, and if you are going to use the double hyphen sign everywhere, then again, it's you're not going to benefit much from the language features. And then we went through some very basic data types. We saw what top level functions are. Top level functions, you can just write them in a file somewhere directly and just use those functions or methods anywhere, even in Java files. So that's what top level functions are. We saw through some basic flow control, which is conditional checks, iterations with for loops. We saw how we can do for each loop for a list, and obviously to go through a range, that a new feature of Kotlin is where we can define a range and just iterate through. And then we saw what when expressions can be used for. There are replacement for switch cases, and how it's easy to just code in a when statement as opposed to a switch statement without any break statements. And then we went through some basic lists and arrays, how we can have mutable, immutable lists. And at the last, we just covered up some class basics. We saw data classes, how we can write one line classes, declare them, and not have a getter, setter, and avoid a lot of boilerplate code. And then we went through interfaces and saw a basic example of a callback. Cool. So I think that has been it. There is more to Kotlin than just this, which is introductory. This session was intended for a very basic introductory level talk. And to those of you who are watching, if you are new to Android and new to Kotlin, know that Android is Kotlin first now. It has a user base of 2 billion active devices. And with Kotlin and with Android, you get to address to that much audience, and you get the power to code and supply your software via Google Play or wherever. And Kotlin helps you enables you to do that, to code for Android, right? and it's a very modern day programming language, what Kotlin is. And the amount of developer freedom you have with Kotlin is better than any OOP. No need to worry about null checks and simple language mistakes. You have to think in terms of human, not a developer, and that's the intent of what how Kotlin got designed in the first place, and to make things easy. And there has been proof of that as well with the data results. So there's much more to Kotlin and much more to learn. This session was intended to cover some basic aspects of programming with Kotlin, an introduction to it. I hope this is helpful. And wrapping it up, thanks for joining. Thanks for attending this event. It will be live on YouTube for you guys to attend and revisit this. Thanks to Kotlin Hyderabad, Raj Mahendra, and Chaitanya for organizing this and making this possible. If you want to connect with me, like I said previously, best place to visit me is my website. Connect with me on LinkedIn or Twitter or wherever you guys feel free. And I'll be of help in whatever form you need some advice with. So hope this has been helpful. Hope there were takeaways that were taken from this entire presentation. Thanks for joining, and I'll see you guys in the next talk that I probably do. Thanks, Chaitanya.
Hey, thank you, Siddhesh. You have given very nice explanation for all the Kotlin basics. So, guys, this is a question time. If you have any questions, please feel free to post in the chat. We will pick it up and Siddhesh can answer them. Siddhesh, let us give a 2 minutes time for the
Yeah, yeah,
viewer.
sure.
I think we don't have any questions right now, Siddhesh.
Yeah,
Anyways, thank you very much
sure,
for
sure.
joining today. We will be expecting more from you, this kind of thing. Yeah. Guys, if you want to have any give any presentation, and you can always come and let us know. The all details are mentioned in the description below. You can always join, and you can always feel free to contact us. That's it from my end. This is end for today. Thank
Yes,
you
thank you
everyone for
guys.
joining us.
Thanks.
Bye bye.
Yes, bye.